Okay, so my name is Do, as Ingrid said, and I'm going to tell you a story about how we migrated one of our most important databases, NoSQL databases, from an older technology to Aerospike. What I want you to take from this story is a very simple and easy to follow methodology that we thought about that makes things easier and will allow you hopefully to migrate large NoSQL database without getting a heart attack. Yeah, you know, usually they show slides and then they say, and one night we flip the switch and we move to the new database. It's never like this. It takes a lot of effort and it's very risky things to do to migrate data. And we've done it several times, and I'm gonna share with you what we've done. Okay. So our agenda for today is very shortly about AppsFlyer and what we do, so get the proper context. Then what we needed to do, what we needed to migrate, how much data did we have, and so on. So we'll get the motivation and the limitations we had, and then what we've done, how we actually migrated the data, and then we actually did it a few more times afterwards, and it worked perfectly. And then a few lessons learned to summarize. Okay. The wrong direction. Yeah. Okay. So AppsFlyer is edtech. Maybe some of you know it. AppsFlyer is an attribution company, a mobile attribution company. We partner with ad networks, and our clients are the advertisers, and we help advertisers to market their apps and optimize their campaigns. To do so, we have an SDK that we supply freely, and everyone can integrate this SDK easily inside his app. And so the SDK sends us events, and we conceive the main part of AppsFlyer as a pipeline, and the pipeline gets events from a cellular device or mobile devices. So currently we have our SDK distributed in around 90% of the world mobile devices, and we process many events. Imagine that we get an event for every app launch, or an event that the client wants us to process. And that's an old slide, but currently we process around 30 billion events per day. And that's a lot. We have to serve these events and to process them. And this processing pipeline has an internal state, which is based on many NoSQL databases, among them now Aerospike. And that's the problem domain we needed to solve. Okay, so let's focus on the actual database that we migrated. So the architecture is a microservice architecture. There are services who write and read from the database. As you can also already see, the old database was Couchbase. There is on the upper side you can see a microservice that writes new installs, new app installs into the database. That's a relatively low rate of 2,000 IOPS. And so imagine that when an app installs, it installs once in a lifetime, and then during the entire app lifetime, it sends us event, for example, for every launch. And so there is another microservice that gets all these lifetime events, and each event read or hits the database, potentially also updates the record, and that's a higher volume of reads. potentially updates, but around 180K read items. So the database is very read intensive. Okay, but we're not happy with Couchbase. We reached a point where Couchbase virtually scaled out of control. A very, very large cluster, around 45 instances. For those of you who deploy on AWS, those are R3.4 extra large instances, or very big instances. I think they have 16 cores, more than 100 gigabyte RAM, more than a 300 gigabyte SSD each. So imagine we had 45 of them. And the cluster was very unstable. XCCR couldn't keep up. Daily backups took more than a day to complete. So practically we didn't back up our database, which is bad. And as an understatement, we weren't so happy with support. And so we've done a few POCs, a few tests. We compared a few technologies, and we chose Aerospike. And now we needed to migrate everything to the new database. So what did we need? We need to migrate, and under which circumstances. So about 2 billion records replicated by 3, so a total of 6 billion needed to move to the new database. As I told you before, the database is a very read intensive, and it has a lot of nodes. It costs us about $30,000 per month. That's only hardware costs, no licensing on AWS. And we have a few months until we need to renew our license with Couchbase. And needless to say, this database is mission critical. We cannot turn it off. We cannot scale it down. It has to stay alive and serve the service. Okay. So a short step back. So why data migration in NoSQL database is so hard? Several reasons. Because if you look at regular standard SQL databases, there are very few big vendors. Every database talks the same language. The data is in a schema. Schema is known in ahead. And every big vendor already wrote a migration tool to migrate the data from the other technologies. So it's a solved problem. But if you're dealing with NoSQL database, it's like a jungle. It's like the Wild West. There are hundreds of vendors. There is no really a schema inside. Every technology speaks a different query language, and there are virtually no out-of-the-box migration tools. You have to do it yourself. Okay, and remember, we have to migrate everything without any downtime, without any data loss. And it's not written here, but the worst that can happen is data corruption. Okay, it's worse than data loss. So now to the methodology that we used. Basically, what we've done is we use the application itself or the microservices themselves to migrate the data. So first stage is very easy to grasp and very easy to implement. You start writing the new data, the data that is newly added to the databases, both to the old cluster but also replicated to the new one. That's it. The data is still served and written to the old database, and the old database is still in service. Wait. Okay. So with this in place, we get to know our database, and we start to see it in action. The most important thing to remember is that whenever things go wrong, and things will go wrong, everybody has bugs, we had many bugs, we'll also write bugs here. You can stop the process, you can kill the new database, you can revert everything. No one will notice, right? So because the old database is still in service, and no one will pay attention. Of course, there are potentially performance implications for doing this, but usually it's better to start like this, start slowly. Okay, but database now start to accumulate data. Now, stop, breathe, test your new database. So, is the sizing what you expected, right? It's easy to do sizing on the Excel sheets, but now you see your database size in action. You see the use this space. Is this what you expected? Is the expected load in the ballpark we thought it will be? Of course, it's only writes, no reads, but you can expect something to happen. It's time to configure metrics on your database. All the telemetry needed to hook the alerting system to it, to look at the database logs, to get to know to it. Remember, it's going to be your next best friend. You're going to use it very extensively. You need to get to know to it. Ops need to get to know to it. It's a new technology in the organization. It's very important to stop at this stage and to get to know. Of course, configure backups. More importantly, try to restore from those backups. This is the point that you want to find that you cannot able to restore and fix it. In 1 year, it will be too late. Now the second phase. Second phase is a little bit more complex, but also very easy to understand. We start reading from the new database. We are still writing to the new database and the old database, but we also start reading, serving from the new database, and falling back to the old database. So for each record we want to find, we write the new database, we miss, and then if we miss, we fall back to the old database. We can miss also there, but that's an applicative miss, it's okay. And now the case that the application misses on the new database and hits on the old database means that the record wasn't migrated yet. So you configure a metric on this use case, and this hit-miss metric is important because the moment that it diminishes to 0 is an indication that the migration is over. So when you see no miss-hit metrics for a time, you know that everything was migrated naturally by the application to the new database. Still, in every second you still find some kind of bug, some kind of data corruption. The old database is still intact. It still has all the data. You can revert everything, go to square one, and start again after you fix your bugs. Now this is more risky, but we are now in a more confident place. And my recommendation is to do this gradually, maybe app by app, API by API, customer by customer. Of course, keep your VIP customers at the end of the line. You don't want your bugs to affect the VIP customers, so start with the non-VIP ones. We're not deleting everything yet. Yes, we have 2 live clusters on production. We are wasting money, but it's money well spent. And yeah, that's it. So now it's a good opportunity to stop and test again. So the new database it's a good opportunity opportunity to start scaling it out, bring it to the new to the right like scale that you want to have in production eventually. So it will get bigger with time as long as the data is accumulating, reads are hitting, you need to resize it. It's a good opportunity to practice resizing and see if it works. And actually every point that I was talking about in the last like breathing slide is also true here. Just iterate again and see that everything is working. Okay, so in many cases, this is it. If you see your hit miss metric goes to 0, you're done. It will be mostly true where data is short-lived. It has low TTLs, and so you can say, yeah, my miss hit metric is 0, like, I don't know, like for a month. I know for sure that whatever wasn't migrated for sure got evicted or deleted from the old database. I can throw my old database away, but that is not true in all cases. Especially in our case, it wasn't true because we had many records that could survive like 6 months or even a year, and we didn't have this time to like operate 2 fully fledged clusters side by side. And then, in that case, you have no choice but to write your own manual migration. And so the scheme of this migration looks a bit like this. So we wrote 2 simple services. One is called the dumper and one is called the loader. We connected them with a buffer. We use Kafka for that. I'll soon explain why. The dumper just queries the old database and gets the entire key set out of it, streams keys via Kafka to the other side. And the loader is also very simple. It just takes the keys, query the new database to see that it's not overwriting stuff. In Aerospike, it's easy to do using policies, and writes without overwriting anything all the keys to the new database. I'll soon continue, but I wanted to do a small detour about how the hell we are querying the entire database. And also, a good question might arise here, and you should ask, hey, but this is simple, so why didn't you start like this? And this is less risky, and this solves the entire problem, right? So yeah, but querying the entire database is risky. We had, and you might also have, a very non-stable database, and creating a view which duplicates the entire key set might be risky, might have performance implications. It was too risky to do, and so we waited for IOPS to drop on the old database, and then we had the chance to do it. So how can you query a NoSQL database with something like a select star? We want all the key sets. So most of NoSQL database, not just Couchbase, has some kind of a similar API. Redis has a globbing mechanism. Aerospike has UDFs. Couchbase has this map-reduced JavaScript API. CouchDB has a similar API. It comes in a bit different manner in every different technology, but the idea is the same. You create an index or a view. Every technology has a different name. And what we need to do here is the most naive view. The most naive view here implemented with like a map function. This is a JavaScript map, a bit simplified, but it says, hey, I want a view of the entire keys, no filtering, just give me the key itself, which is the document ID, and its TTL, which is the expiration field, and also Couchbase were very nice to sort the keys by the TTL. So what we got is that the keys with the shortmost TTL, so that the oldest keys were ordered first in the index. And yeah, an important point here is that you don't want the record itself to be a part of the view, because this will practically double the info, the data on the database. The index of the view should only be composed of keys, so be aware. And so you can create like a query that returns the entire key set from the database. It's possible in almost all NoSQL technologies. And so once you query the database and get the entire key set, all you need to do is to string the keys into your message queue. We use Kafka. Kafka serves here as a buffer, both for overrun or underrun problems, because the dumper or the loader might operate in a different rate. And also, Kafka stores the messages for as long as you want to, so the loader can do its idempotent process over and over again. Assuming you find that it's not working, you can just restart it, even long after the dumper finished writing all the keys to Kafka. So the keys in Kafka can stay as long as you need them. And that's it, basically. So for a few, so let's take a look about the new Aerospike cluster that replaced Couchbase. So again, 2 billion records. Now we had a different topology. We had 2 availability zones connected with XDR, a 2-way XDR. Each cluster has a replication factor of 2. So now practically we have 4 copies of every record instead of 3 in the old cluster. IOPS were same and are still growing to this day. Number of machines, you can count here only 10. Of course, different instance type, because we needed to use the latest generation of SSD, but the cost is like 1/3, and we were happy. So a few lessons learned to summarize. So first, planning. Okay, plan how do you want to migrate and when. Plan how long it will take you. Plan what you want to test on each phase and what do you expect to see at each phase. It's important so you don't get any surprises. Do it gradually. You will have bugs. It happens to everyone. We are all human. So you want those bugs to affect your non-VIP customers first. So if you can do it, graduate, roll out, and serve the less important data first from the new database, do it. Stop and test. And more than testing, stop and wait. Give the new database some time to live. Some problems may occur or may arise after time is passing. Not only, maybe give the new database like a weekend to operate. If it has faulty SSDs, if it has problems in configuration that will only raise their head after you cross a certain threshold of throughput. Give it time, don't rush. And of course, do not delete everything do not delete anything, sorry, until you absolutely have to shut down the entire old database. I don't know, but whoever pays the money for that will surely push you. But stay calm. The money that is spent here by on operating two clusters in parallel is well spent. I mean, the cost of a mistake, the cost of data corruption, of unhappy customers is a lot higher. So be strong and take your time. And I think that's it. Thank you.
So how much data was transferred, and how long did it take you from kind of start to finish, even with all of your safety stops?
Okay, so we had about 2 billion records. I don't remember the byte count, but you can do the math. It's replicated 3 times, and each record was about 1 kilobyte JSONs. So it's a lot of data. It took us about 2 months, and in between we reverted stuff, we discovered bugs, we reconfigured the database. It was the first time we used Aerospike, so it took time to learn how to operate it, how to configure it. No many support cases. Aerospike support was excellent there, but it takes time. It's a long process. It's never like flipping a switch. Yeah.
Hi.
Yeah.
Hey, thanks for sharing your migration story, and many more success to you in future. I know I was looking at one of the slides where you said costs went down, but cost became 1/3 of what you were paying before. Other than cost, if IOPS and number of records and year-on-year number of records increasing is still the same, why did you change from Couchbase? I was trying to find that in this whole presentation and I could not.
So maybe you missed the slide, but we weren't very happy with Couchbase. Couchbase deserves the credit to bring us to where we were, so a few years of successful operation, but it got to a point on a scale that it just couldn't do it anymore. It was unstable, I couldn't scale out, every time we lost a node, and when you have 45 nodes, it happens like once a month. It increased latency, adding back the node also increased the latency. Support were unhelpful. We felt that it is on a point that we cannot count on it anymore, and we want to sleep better at night.
Is this something you can share after the session? I would be interested to.
Yeah, no problem.
Thank you.
Yes. Hello. During your migration, did you, question number 1, did you migrate all the records from Couchbase to Aerospike, or you discarded something, or you applied some filtering rule?
No, everything needs to be migrated. It's like customers' data, so
Okay.
we cannot afford to throw anything on the floor.
Okay, and I hope the second answer I know, but still I'm asking. Did you do any kind of data transformation while migrated, like you merged records, you split records, or any kind of thing you can think of? Or?
Okay, the short answer is basically no, but the long answer is that you always have to do some kind of transformation. I'll give you the most simplest example. TTL itself, which is not the data, but the metadata, is represented in a different form on Aerospike than on Couchbase. So, however you look at this, there is some kind of data transformation to do. Maybe on the old database, you did something, and then on the new database, you say, hey, why don't I use gzip now? I don't know. It's a good opportunity to start using it. So, it will happen anyway, even if you don't touch the data.
So then I have a third question. I mean, how did you do that transformation? You wrote some application or anything?
So if the application does it, you can do whatever you want with the application. So basically it ends with maintaining like 2 clients with 2 like data layers. The old data layer stays the same and the new one just writes new stuff as it should, as you want it to write.
Thank you.
So I have a question on the Couchbase bit. So if you look at the key structure, I believe Aerospike will compress the key down to 20 bytes, regardless of the size of the original key.
Yeah, it's hashing.
It's hashing. On the Couchbase side though, if you have made the choice for a very long key, what Couchbase does is to keep the key plus 56 bytes of metadata plus the value in memory, whereas in Aerospike, you would keep the index only in memory, right? So there is an optimization there, which I think is showing up probably in your cost and the scale. But my question is, on the Couchbase side, what was the length of your key? Did you have something? There's a factor there called the active resident ratio. How much of the ratio sits in memory when the memory is full and things like that? Did you have any analysis on that?
Yeah, I can tell you the basic analysis. So the key was longer than it should have been. You make a decision and you don't expect a scale like in 3 years. So it was longer than it should be. Maybe we needed on day 1 to hash it on the application, but we didn't. But on the other side, Couchbase uses the entire RAM. So it's very efficient in the way that it utilizes RAM. In Aerospike, on the other hand, it's very rigid. So the RAM usage is what it is. And if you buy an instance from Amazon, which has a fixed ratio between disk and RAM, you end up with one of them underutilized, and you cannot play with it. So but still you can see that we saved a lot of money.
I have a follow-up question.
Yeah.
So the follow-up question is, did you already have an existing view that you used, or did you create a new view when you did the last bit of checking for the long tail?
No, we use a very naive, very simple key value access. We never use, they have, on the throughput we have used, actually doesn't hold the scale. So what we actually did, and they didn't tell about it, is that we were so afraid for Couchbase to fall apart when we created the view that we backed it up, restored it to another cluster with a lower replication factor, created the view on the new cluster, and then queried it.
Yeah.
That's how scary we were.
Got it.
Yeah. Anyone? Okay, thank you.
Ido, thank you. Very interesting.